Hello, everyone, and thank you for being here today. Our presentation is about large language models, also known as LLMs, and how they are transforming the field of natural language processing. So, before we begin, let me introduce our team. I'm Kusuma Kankanala, and I'm presenting this project with my teammates Shinisai Mahati Polavarpu and Gautam Injeti. So, today, together we have explored how powerful AI models like GPT-4 and BERT have reshaped the way machines understand and generate human language. So, here in this presentation, we'll first look at what NLP is and how it evolved over time, and then we'll explain what LLMs are and how their key architecture is. So, the transformer works and the highlight some of the major models in use today. So, we will also walk you through how these models are trained and their real world applications and the challenges and ethical questions they raise. So, finally, we'll look at what the future might hold for NLP and AI as these technologies continue to grow. By the end, you should have a solid understanding of how large language models work and why they are so revolutionary and how they are influencing nearly every digital interaction we have. So, let me go to the introduction to NLP. So, to begin, let's understand what NLP actually is. So, NLP is a subfield of artificial intelligence that helps computer interact with humans using natural language. So, the language we use in everyday life. The core goal of NLP is to make it possible for computers to read, understand, interpret, and generate human language in a meaningful way. For example, when we use Google Translate, Siri, Alexa, ChatGPT, or even simple tools like autocorrect, so all of these rely on NLP techniques. So here, NLP combines linguistic, computer science, and machine learning. So, linguistic helps analyze grammar and structure, which machine learning helps computers learn patterns from massive amounts of text data. So, here there are two key components of NLP. One is natural language understanding, and another one is natural language generation. Here, NLU focus on making sense of human input, and NLG helps systems to produce natural sounding text responses like writing, summarizing, or chatting. So, in short, NLP is the bridge between human communication and machine intelligence. So, it's what makes AI conversational, interactive, and context aware. So, here the next slide is about the evolution of NLP. So NLP has come a long way from simple rule-based system to today's highly intelligent models. So let's walk through this evolution step by step. In 1950s to 1980s, NLP was rule-based. So the experts wrote thousands of linguistic rules manually, but the computer followed grammar and syntax patterns to analyze sentences. Here, the problem was that languages are messy but filled with exceptions and ambiguity. Rule based systems simply couldn't capture real world languages but complexity. So, in 1990s and 2000s, things changed with statistical NLP. So here the models like hidden Markov models and naive Bayes were introduced. So instead of relying on fixed rules, systems started learning from large data sets using probability and statistics. So here this was the era where machine translation, basic sentiment analysis, and parts of speech tagging became possible. Then came the deep learning era. It in 2010. So neural networks, especially recurrent neural network called RRNN and long short-term memory LSTM models started learning long-term language dependencies. But the real evolution happened in 2017 when Google introduced the transformer architecture. So this model used a mechanism called self-attention, which allowed it to process text from more effect- efficiently and in parallel. So from the point onward, we saw the rise of BERT, GPT, T5, PALM, and many others, all built on transformer technology. So the evolution of NLP can be summarized as rule-based, statistical, deep learning, transformer-based NLP. So in the slide 4, we gonna talk about what are the large language models. So LLMS stands. Now that we understand about NLP, let's look at what large language models are. For example, a language model or LLM is a type of AI system that has been trained on enormous amounts of text data to understand and generate human like language. So these models are called large because they contain billions or even trillions of parameters. These parameters are the model's internal knowledge learned during training. So think of an LLM as a advanced text predictor. So it does not just look at one word, but it analyzes entire sentences and paragraphs. So to predict the mostly likely continuation of the text. So, by learning from books, Wikipedia, and websites and conversations, the model builds a vast understanding of grammar, facts, reasoning, and the patterns, even creatively. For example, GPT-4, which parse GPT, ChatGPT has hundreds of billions of parameters and can perform tasks like writing essays or emails or translating between languages, summarizing large type of documents and answering complex reasoning questions, sort of. And these models are general purpose meaning. So the same base model can perform many tasks without retraining. So they are transforming industries like education, healthcare, customer service, law, and more by making text based automation much smarter and more natural. So for the next slide, we're going to talk about key architecture, the transformer. So the transformer architecture is at the heart of almost every model in LLM. So it was introduced by Vaswani et al. In 2017 in a paper titled Attention is All You Need. So it replaced older architectures like RNN and CNNs that struggle with long test sequences. So the key innovation of the transformer is self-attention. This mechanism, it allows the model to focus on different parts of a sentence at once. So understanding how words relate to each other even if they are far apart. So, for example, in the sentence, the cat that chased the mouse was hungry. So, the model learns that was hungry refers to the cat, not the mouse here. So, transformers have two main components, one is encoder and another one is decoder. Here, the encoder processes the input text and captures its meaning. But coming to decoder, it generates the output text based on the processed information. So here the models like BERT use only the encoder for understanding text. So either for good or for classification, sentiment, or question and answers. So models like GPT use only decoder for text generation. And hybrid models like T5 use both the decoder and encoder. So transformers are powerful because they can process text in parallel, making training much faster, and they capture rich contextual relationships between words. So, this design made it possible to train extremely large models efficiently. And next slide's gonna be explained by me.
Hey everyone. Now let's talk about some major LLM models. There are many LLMs developed by research labs and tech companies around the world. Let's look at some key examples. They include GPT, BERT, T5, PALM, LLAMA, Cloud. So let's talk about each. So firstly, GPT, the generative pre-trained transformer. So they include GPT-2, GPT-3, GPT-4, known for conversational AI, reasoning, and creativity. And the next one is BERT, that's Google. So bidirectional encoder representations from transformers. It revolutionized understanding tasks like sentiment analysis and question answering. And the next is T5. Google also uses this. So that is text-to-text transformer. Treats every NLP problem as converting one piece of text into another. And the next is PALM. So that's Google DeepMind, a massive LLM with 540 billion parameters capable of reasoning and multilingual understanding. And the next one is LLAMA. That is open source models for research and fine tuning widely used in AI community, maybe Meta. And the last one is Cloud. That's Anthropic. This focus on safe and aligned AI behavior optimized for long context understanding. These models vary in size, architecture, and purpose, but they all share the same transformer foundation. Their advancements have rapidly improved tasks like translation, summarization, code generation, and even image captioning. And the next one is training process. In training process, a LLM is a complex and expensive process. It typically happens in three major phases. They are retraining, fine-tuning, and reinforcement learning from human feedback. It's oral itself. So let's learn about the first one. That's pre-training. The model is trained on massive data sets, including books, articles, websites, and code. During this phase, it learns general patterns in language, grammar, facts, and reasoning. And the next one is fine tuning. In this, after pre-training, the model is specialized for specific tasks like summarization or question answering, etc. Tuning uses smaller, more focused data sets. And the last one is RLHF. This is a crucial step for alignment. Human evaluators rate model responses, and the model learns to generate helpful, safe, and contextually appropriate answers. This is what makes system like ChatGPT feel more human and natural in conversation. Training LLMs requires enormous computational resources, sometimes thousands of GPUs and weeks or months of processing. The result is a model capable of understanding language almost like a human, but faster, scalable, and tireless. And the next slide is LLMs in NLP applications. Large language models have a wide range of applications in NLP. Here are some major areas where there are some things that is making a real impact. And that is text generation, summarization, translation, question answering, sentimental analysis, information retrieval. In text generation, it includes writing essays, poetry, code, or stories. In summarization, condensing large documents into short, meaningful summaries. And in translation, converting text between languages with human level fluency. And in question answering, powering virtual assistants, customer support bots, and chat interfaces. In sentimental analysis, understanding emotions and opinions in text. And in information retrieval, enhancing search engines and document analysis tools. And in healthcare, assisting doctors by summarizing patient notes or explaining medical literature. Essentially, any task that involves understanding or generating text can now be powered by an LLM. They are not just improving efficiency, they are changing how humans and machines collaborate. And the next slide is like examples, and let's talk about an example use case that is ChatGPT. Let's look at a specific and familiar example. That's ChatGPT. ChatGPT is built on the GPT-4 architecture, which uses the transformer decoder model. It can understand context, generate detailed responses, perform reasoning, translate languages, and summarize text, and more, all through natural conversation. What makes ChatGPT remarkable is it's the use of reinforcement learning from human feedback. This training approach teaches the model to respond more like human, like polite, and context aware and adaptive. For example, if you ask it to summarize a long article or write an email, it understands the tone, length, and intent of your request. This makes ChatGPT an excellent demonstration of how far LLMs have come from basic NLP systems to intelligent conversational partners. In the next slide, let's learn about the advantages of LLMs. There are several major advantages to using large language models. They include generalization, zero shorthand, few shot learning, contextual understanding, reduced data labeling effort, human like communication, and etc. Let's learn about everything in detail. So, in generalization, LLMs can handle multiple tasks from translation to summarization without needing task specific models. And the next one is zero shot and few shot learning. These models can perform new tasks with little or no training data. For example, GPT can summarize a text even if it's never been explicitly trained to do so. And the next one is contextual understanding. Transformers enable deep comprehension of context, meaning, and relationships between words. And the next one is reduced data labeling effort. Traditional NLP required large labeled data sets. LLMs can learn patterns from raw, unlabeled text. And the next one is human like communication, the most important one. They can mimic natural conversation, understand nuances, and even express creativity. These benefits have made LLMs foundational tools for next generation AI systems, you know? And my friend will continue the rest of the slides.
Thank you, Mahati, and myself, Gautam Injeti. Let's discuss about the challenges and limitations. Despite their strengths, LLMs also face several limitations and challenges. And let's move to one by one. The high computational cost. Basically, this training and running large models require massive hardware and energy resources. And but in the databases, since LLMs learn from internet data, they can observe societal biases or stereotypes or false information. And the third one is hallucination. Sometimes models generate convincing but incorrect information. A major challenge is factual accuracy and the lack of true understanding. While models seem intelligent, they don't understand in the human sense. They predict the based on the patterns or not reasoning. And coming to the privacy concern, the data used for the training may include sensitive or copyright material. And the sixth one is the ethical and regulator issues. Misuse of LLMs for misinformation or harmful content remains the growing concern. And recognizing these limitations is a crucial to using the LLMs responsibly. Next, Muthura, next slide. This slide covers about the ethical concern. Ethical ethics play a huge role in NLP and AI development. As this model become more powerful, we must think carefully about how they use it. Some key ethical concerns include biases and fairness, ensuring models don't reinforce discrimination or stereotype. The transparency users should know when they are taking to an AI and how it makes its decisions. And misinformation, preventing the spread of fake or misleading information generated by AI. Data privacy, making sure that personal or confidential data is not misused. Job impact, as AI automates more languages tasks, we must consider its effects on employment and society. Basically, this addresses these issues required collaborating among developers, policymakers, and users to ensure AI remains safe, fair, and beneficial. Let's move to the next slide. Yeah, okay. This slide basically covers about the future of NLP and LLMS looks extremely promising. We can expect smarter and smaller modules. These efficient models that perform well even on personal devices. And coming to the multimodal AI, basically these systems that can understand not just the text but also images, audio, and video together. Personalized assistance. The tailored AI that adapts to individual while respecting privacy. Improved reasoning and factual accuracy. Models that can verify their outputs and explain their reasoning. And the last one is responsible AI framework. Basically, the stronger focus on fairness, safety, and human alignment. We are moving towards the future where AI does not just process language, it also understands and collaborates with meaningfully. And next slide, we're going to discuss about the summary. The NLP enables the computers to understand and use human language. Over decades, NLP evolved from the rule based systems to powerful transformer based models. Large languages models like ChatGPT, BERT have redefined how we approach text, translation, and communication. They, being, they bring incredible advantages like challenges around bias, accuracy, and ethics. But coming to the future of NLP will focus on balancing innovations with responsibility. LLMs are also just tools. They are just stepping stones towards the world where technology truly understands human thought. And this slide covers about the references where you can find more information from the papers and the resources we referred to, including Attention is All You Need by Vasvi, um, 2017, OpenAI ChatGPT services serves research papers, Googlebot and DeFi documentation, Anthropic's research on model element and safety. And thank you for all listening. We hope you found the presentation insights and thank you very much.